Now let us discuss the some important questions in the thermodynamics chapter. So now I will discuss the one by one. The enthalpy of combustion of the liquid benzene is minus 3250 kilojoules when 0.39 grams of the benzene is burnt in excess of the oxygen in open vessel. What is the amount of the heat liberated? So here enthalpy of combustion of the 1 mole of the benzene is given. Now we have to calculate the amount of the heat liberated when 0.39 grams of the benzene burns. Question number 1. For 78 grams of the benzene, the heat liberated is 3250 kilojoules. 350 kilojoules. Therefore, for 0.39 grams of the benzene heat liberated is. So in the problem they have given that amount of the heat liberated for the burning of 78 grams. We have to calculate the amount of the heat liberated for 0.39 grams. Therefore the solution is 3250 upon 78 into 0.39. So answer is 16.25 kilojoules. Answer is B. Question number 2. In order to decompose 9 grams of the water, 142.5 kilojoules of heat is required. Hence, the enthalpy of formation of the water is. So in the problem, they are given the amount of the heat required to decompose 9 grams of the water. Therefore, let us represent the decomposition reaction of the water. This is the decomposition reaction of water. So here according to the stoichiometry, 18 grams of the water is participating. But in the problem, for 9 grams of the water, they are given the heat required. Therefore, first to calculate the quantity of heat required for decomposition of the 18 grams. For 9 grams of water, heat required. Heat required is 142.5 kilojoules. Next, for 18 grams of the water, for 9 grams of the water, heat required is given as 142.5 kilojoules. Therefore, first to calculate the heat required for the decomposition of the 18 grams of the water. So, for 18 grams of the water, the calculation is 142.5 by 9 into 18. Therefore, this is 285 kilojoules. Next, based on this heat required to decompose the 18 grams of the water, now we have to calculate the heat of formation of the water. For that purpose, first to construct the formation reaction for the water. While constructing the formation reaction of the water, first you put 1 mole of the water on the product side, then you take the suitable moles of the reactants on the reactant side. Next, this formation reaction is exactly opposite to the decomposition reaction. Hence, the magnitude of the enthalpy change involved is the same but with opposite sign. Hence, enthalpy change. Hence, enthalpy change is minus 285 kilojoules per mole. Therefore, answer is D. The heat of formation of the CO2 gas, CO gas and H2O gas are minus 393.5 kilojoules per mole, minus 11.5 kilojoules per mole and minus 241.8 kilojoules per mole. The standard enthalpy change in kilojoules per mole for the reaction CO2 plus H2 gives CO and H2O. The reaction is CO2 gas plus H2 gas. Here CO gas plus H2O gas. So for this reaction, they are asking the enthalpy change. Here, so they have given the enthalpy of formation of the various participating species. So whenever if the enthalpy of formation of the reactants and products are given, if they ask the enthalpy change for the reaction, the formula is enthalpy of the formation of the products minus enthalpy of formation of the reactants. Here products are carbon monoxide and H2O. So for carbon monoxide, the enthalpy of formation is given as minus 11.5, and for water, the enthalpy of formation is given as minus 241.8. Next enthalpy of formation of the CO2 is given as a minus 393.5. Next, the enthalpy of formation of the hydrogen. See, the standard enthalpy of formation of the elements is always 0. Therefore, here this is another value is 0. Now we want the result. The total enthalpy change of the products is minus 253.3 minus of minus plus 393.5. So answer is plus 140.2 kilojoules per mole. So answer is B. Question number 4. Given the enthalpy of formation of the carbon dioxide is 94 kilojoules and that of calcium oxide is minus 152 kilojoules, and the enthalpy of the reaction is CaCO3 gives CaO plus CO is 42 kilojoules. Find the enthalpy of formation of the CaCO3. So the reaction given is CaCO3 gives CaO plus CO2. CO2 is in the gaseous state, CO is in the solid state, it is also in the solid state. For the whole reaction, they are given the enthalpy change. So enthalpy change. Next, for calcium oxide, they are given the enthalpy of the formation, and calcium oxide enthalpy of formation is given, and for carbon dioxide also enthalpy of formation is given. Next, we want the enthalpy of formation of the CaCO3. That means in general, for a given reaction, if the total enthalpy change is given, in the same problem, if the enthalpy of the reactants and products are given, the formula is enthalpy of formation of the products minus enthalpy of formation of the reactants. Here the net enthalpy change taking place in the reaction is given as 42 kilojoules per mole. Next, enthalpy of formation of the products. Enthalpy of formation of the product. One product is calcium oxide. So the enthalpy of formation of the calcium oxide is minus 152. Next, formation of this. Next, CO2 is minus 94. Next, enthalpy of the reactant. Calcium the enthalpy of the calcium oxide CaCO3 is. So enthalpy of the formation of the calcium oxide is minus 152. Enthalpy of formation of the CO2 is minus 94. Minus of enthalpy of formation of the CaCO3. Therefore, this is minus 246 minus enthalpy of formation of the CaCO3. Therefore, you bring minus 246 this side. So 42 plus 246 is equal to minus enthalpy of formation of the CaCO3. Therefore, enthalpy of formation of CaCO3 is 288. You bring minus side to this side, so it becomes plus. So the enthalpy of formation of the CaCO3 is plus 288 kilojoules per mole. Therefore, answer is D. Question number 5. Equal volumes of the 1 molar HNO3 and 1 molar H3PO4 are neutralized by the dilute NaOH solution. If X and Y kilocalories of heat are liberated in these reactions, the relation between X and Y, assume H3PO4 is completely ionized. So in two separate experiments, they are taking the HCl and the H3PO4. Next, the molarity of the HCl is 1m. Molarity of the H3PO4 is also 1m. Next, equal volume. Say, let us say volume is equal to V here, V liters. Here, let us say volume is equal to V liters. Next, when H3PO4 completely ionizes, the molarity of the H plus ions here becomes 3. Next, molarity of the H plus ions here becomes 1. Molarity of the H plus is 1. Therefore, you calculate the moles of the H plus ions present in the HCl, moles of the H plus ions present in the H3PO4. moles of H plus is equal to 1 into V. Similarly, moles of H plus. So here moles of the H plus. Here 3 into V, so 3V. So in this H3PO4 solution, the total moles of the H plus ions are 3 times greater than the moles of the H plus ions present in the HCl. Now in this condition, if add the sodium hydroxide into this solution and sodium hydroxide into this solution, when sodium hydroxide is added into both these acidic solutions separately, since here more number of H plus ions are present, more degree of neutralization takes place. Here more amount of the heat will be liberated. Here less degree of neutralization takes place, hence less amount of heat will be liberated. Therefore, amount of the heat liberated here is more and amount of the heat liberated here is less. Therefore, from the solution where H3PO4 is taken, more amount of heat is liberated. Here less amount of heat is liberated. Next in the problem, they are given that heat liberated from HCl is X and heat liberated from H3PO4 is Y. Therefore, according to this relation, so Y must be greater than X. Answer is Y is greater than X. Therefore, B. Because in the option B, they are given that X is equal to 3Y. So, Y is greater. Question number 6. So, in the given problem, if the heat of neutralization of the strong acid and strong base is given, in the same problem, if heat of neutralization of the either weak acid or weak base is also given, first compare the numerical values. Whenever if the weak acid or weak base participates, the amount of heat liberated will be usually less when compared to the heat liberated if strong acid or strong base participates. Therefore, in the problem here also, the heat of neutralization of the HCl with NaOH is given as 13.7 kilocalories. Next, in the same neutralization reaction, if the ammonium hydroxide participates, the amount of heat liberated is 12.27 kilocalories. Therefore, if we compare the numerical values, since the ammonium hydroxide is a weak base, therefore less amount of the heat is generated because of less degree of ionization. Hence, the degree of ionization can be calculated through that standard formula like this. Heat of ionization. Heat of ionization of ammonium hydroxide is heat liberated minus heat of neutralization. Heat of neutralization of strong acid, strong base. Heat liberated. Here heat liberated is 12.27 minus 13.7. This is therefore heat of ionization is 1.43 kilocalories per mole. Therefore, answer is D. Question number 7. The heat of neutralization of the sodium hydroxide with HCl is 57.3 kilojoules and with HCN it is 12.1 kilojoules. The heat of ionization of the HCN is. So therefore, this it is also like a previous problem. That means whenever if they ask the heat of ionization of the weak acid or weak base, apply the standard formula like this. Heat of ionization. Heat of ionization is heat liberated when weak acid or weak base participates. Minus heat of neutralization. Neutralization of strong acid, strong base. Heat liberated when the weak acid or weak base participates is given as 12.1 minus 57.3. 57.3. Therefore, the answer is 45.2 kilojoules per mole. Answer is B. Question number 8. Del X is given as hydration energy minus lattice energy for a salt. Del X is found to be 500 kilocalories per mole. Therefore, on increase in temperature, what is the solubility? How it changes? Increases, decreases, remains same, increases. Therefore, usually if the sum of the hydration energy and lattice energy is positive, therefore we can say that the dissolution process is endothermic. Since the dissolution process is endothermic, therefore with rise of temperature, the dissolution process always increases. Hence, answer is increases. Answer is A. Question number 9. 4 grams of NaOH is dissolved in water. 4 grams of HCl is added into the same solution. Therefore, the heat generated in kilocalories per mole is. Here in the experiment, they have taken 4 grams of the NaOH. 4 grams of the NaOH. Therefore, convert these 4 grams of NaOH into equivalents. 4 by 40. Equivalence is 0.1. Next, into the same solution, now they are adding the acid. Here the added acid is a strong acid, HCl. Next, the amount of the HCl added into the solution is given as 4 grams. Convert this 4 grams also into equivalents. For HCl, the gram equivalent weight is 36.5. 36.5. So therefore, here we will get slightly more than 0.1. Slightly more than 0.1. Next, represent the neutralization reaction between HCl and NaOH. The neutralization reaction is NaCl plus H2O. According to the principle of heat of neutralization, X equivalents of the first reactant always combines with X equivalents of the second reactant. Here, one reactant is taken in lesser proportion, another one is taken in more proportion. Therefore, the reactant whose equivalents are lesser will completely participate. Here, which is lesser? Sodium hydroxide. How many equivalents of sodium hydroxide are taken? 0.1 equivalent. Therefore, sodium hydroxide equivalents are 0.1. Hence, equivalents of HCl required in this reaction should also be 0.1. Hence, the total amount of the sodium hydroxide will participate in the reaction. Therefore, proportionate amount of the heat will be liberated. Next, according to the principle of equivalence, whenever if one equivalent participates, the amount of heat liberated is 13.7 kilocalories. If 0.1 equivalent participates, how many? How much? 10 times less, 1.37 kilocalories. The answer is 1.37 kilocalories. So, in which option 1.37 kilocalories is given? Answer B. Question number 10. In which of the following reactions the heat liberated is known as standard heat of formation of CO2? So, for the standard formation reaction, what you have to do is observe the number of moles shown on the product side. On the product side, always 1 mole must be shown. Next, that product should be in its standard state. Say for the formation of the CO2, the number of moles of the CO2 on the product side must be 1. And the physical state of the CO2 should be gaseous state. Next, for the formation of 1 mole of the CO2, we need 1 mole of the graphite. We need 1 mole of the graphite. Next, we need 1 mole of the oxygen gas. So, the reaction in which 1 mole of the graphite combines with 1 mole of the oxygen to give 1 mole of the CO2 is the correct representation of the standard heat of formation of the CO2. So, in which option it was shown like that? You see, in C option, graphite plus O2 gives CO2 is given. Therefore, answer is C. Question number 11. Equal volumes of the molar HCl and H2SO4 are neutralized by the dilute NaOH solution. And X kilocalories, Y kilocalories of heat are liberated respectively. Which of the following is true? So, here molar HCl, that means in one solution they have taken the HCl, in another solution they have taken the H2SO4. So, molarity of the HCl is given as 1, molarity of the H2SO4 is given as 2. Next, equal volumes. See here volume is, let us say V. Here let us say volume is equal to again V. Next, both are strong acids. Therefore, moles of the HCl or moles of the HCl is equal to moles of the H plus. Moles of HCl is equal to 1 into V, that is V. Therefore, moles of H plus is V. Therefore, moles of H2SO4 to V. Therefore, moles of H plus to V. Next, now in this first solution, total moles of the H plus are V. In the H2SO4, total moles of the H plus are 2V. That means here total moles of the H plus ions are more. Therefore, more degree of neutralization takes place. Hence, more amount of the heat will be liberated here. Here, less amount of the heat will be liberated here. Here, the quantity of heat liberated from the HCl is given as X. Here, the quantity of heat liberated from H2SO4 is given as Y. Next, this Y is more and X is less. So, therefore, relation between X and Y is this one. Next, the exact quantitative relation is, see, this is 2 times more than this one. That means this is 2 times more than this one, means the quantitative relation is 2x is equal to y. Therefore, x is equal to y by 2. Therefore, answer is B. Question number 12. Liquid benzene burns in oxygen according to the given reaction. Therefore, how many liters of the oxygen is required for complete combustion of the 39 grams of the liquid benzene? So, I will represent the combustion reaction for the liquid benzene. C6H6. Next, 15O2. Here I will take 2 moles. Therefore, 12 CO2. Next, H2O. That means 6H2O. 6H2. This is the balanced equation. Now, if 39 grams of liquid benzene participates, how many liters of the oxygen is required? See, according to the stoichiometry, 2 moles of the benzene requires 15 moles of the oxygen. So, let us assume this reaction is taking place at the STP conditions. So, therefore, convert this 15 moles of the oxygen into the corresponding volume. Therefore, for 2 moles of the liquid benzene, 2 moles means 2 into 78 grams of benzene, volume of oxygen required. Volume of the oxygen required 15 into 22.4 liters. Next, for 39 grams of the benzene, volume of O2 required. To 39. So, we will get the 84 liters. So, for 2 moles of the benzene means 2 into 78 grams of the benzene, volume of the oxygen required is 15 into 22.4 liters. For 39 grams of the benzene, volume of the oxygen required is, this is the calculation. Therefore, total amount of the oxygen required is 84 liters. Therefore, answer is D. Question number 30. The relation between enthalpy change and internal energy change for the reaction PCl5 plus Cl2 gives PCl5 is. I will represent the reaction PCl3 plus Cl2 gives PCl5. Here for this reaction we want the enthalpy, relation between enthalpy change and internal energy change. The expression which shows the relation between enthalpy change and internal energy change is enthalpy change is equal to del U plus del N RT, where del N is the number of moles of the gaseous state products and reactants. Therefore, first calculate the change in the total number of moles. Total change in the total number of moles means total moles of the gaseous state products minus total moles of the gaseous state reactants. Here products is 1, reactants is 2. Therefore, minus 1. Therefore, del H is equal to del U minus RT. Therefore, according to this expression, so del H is equal to del U minus RT. Therefore, del U must be greater than del H. Answer given in the problem is B.